So we're talking about locating roots, and there are two contexts where we find that. We either find that in solving equations equal to 0. So what are the values of x that make this bit of algebra equal to 0? Those values of x are called the roots, only when it's an equal 0 equation. Or it might be a graph, and it's asking where does it cross the y-axis? Sorry, x-axis. Where does it cross the x-axis intersections? And the two are interchangeable. Sometimes we are, trying to solve an equation, but we do it graphically. And sometimes we're trying to find something on a graph, where does it cross the x-axis, y-axis, and we do it algebraically. And so, these two methods are really one and the same thing. But what we're talking about are situations where the other things that we've learnt over the years let us down, where we can't work them out. So last lesson we talked about sign change, which basically says if we've got a graph and that graph has a root here, then a value of x one side of the root and a value of the x the other side of the root will give you different y values. In this case, you get a negative value here and a positive value there. So provided the graph is continuous, the sign change indicates that there is a root between those two values. And sign change is rarely used on its own. It's often used alongside one of the other two techniques that we need to cover. Okay? So the first of those two techniques we need to cover is actually good news, because it is a technique. Sorry, I've got all sorts of funny stuff going on here on the computer. It is a technique that we met at GCSE. Oh no, I don't believe it. Sorry. Give me 1 moment. Serenity is okay. Come on. Sorry,
I'm heading down there now.
So the method we're going to look at today is called iteration. Iteration. And we did meet it at GCSE, I think we finished the syllabus when we all went off on lockdown, and I think we had covered it, but of course we're all a little bit rusty, so you can be forgiven for not remembering it. So iteration is a way of doing either this or this. So in this question, we have some algebra, and we're being asked to find where it equals 0. So we're trying to solve this equation. Now, actually, we've got plenty of ways of doing that, so we don't need to use a numerical method in this case. We're just starting with a nice, easy answer, easy question that we can work with. So what iteration does is it rearranges the equation that always should start equal to 0 in the form x is equal to something else to do with x. This is different from a question that says make x the subject, where you have to collect all the x's on one side. This is not what we're after. We're after basically turning this into two separate functions, where one is just an x and the other is something else to do with x. So in this case, can you see what they've done? Or well, can you do it? Can you do the algebra you need to turn this into this? This is what they've done. Okay, so they've given us the rearrangement. Of course, it's not working. Nothing's working today. Can you get to that rearrangement? It's not as straightforward as it maybe seems. So I want you to get from that, well, from this, from equal to 0, to that. there's a helpful little hint here. X can't be 0. So that maybe gives you a bit of a clue as to what they've done. No one.
They're all X. So who would be the best person to go in the sort of system?
I don't know. I mean, I off the top of my head, I don't know who's in what. So I mean, you could go and see whether Dave's supposed to be back here. So you could go and see if he would appreciate some help. I don't know which group he's got at the moment. So this is a rare occasion where we're allowed to divide by X. That's only because we're told in the question that X can't be 0. Okay. So we're looking, remember, for the values of X that make this equal to 0. So because we've done correct algebra, they're the same values that would make this equal this. And the fact that we're using a numerical method probably means that it's not going to be a nice round value. It's probably going to be a horrible decimal number. It may even be an irrational number. It may be a number that we can never write down accurately. So we've got to say, right, let's get it as accurately as we can. So if I had the exact value and substituted it into that equation, the left-hand side would equal the right-hand side. But we don't do that because we don't know the answer. So what we do is we make a guess and we try that value. Now we've already been told that there's a solution between 3 and 4. Now we haven't had to check that, but we could have checked that using sign change with the original equation. But we're told that, we don't need to check that. So what we're told to do is to, okay, start by making x equal 3 in this equation. Now, this looks a little bit like this, but it's got this extra notation. And this notation indicates what we're going to do here. What this notation says is the next x value is something to do with the current x value. So what I'm going to do is make a guess. There's a solution between 3 and 4, so I'm going to guess it's 3 and make x equal to 3 here. And what comes out is my next guess, which I put back in. And what comes out is my next guess, which I put back in. So we're going to start by making this 3. So can you do 4 minus 1 over 3? And see what you get. See what you get. So, 4 minus 1 over 3 gives me my next guess. And so what I then do is I type in the sum again, but instead of 3, I use my new guess. 4 minus 1 over 3. And that gives me my next guess. And then I'd do it again, and it'd probably be better to store that in the memory this time. It's a bit of a faff, isn't it? There's a great shortcut. There's a great shortcut we can use which speeds this process up. So let's do it again using this great shortcut. So what I'm going to do is my first guess, I'm going to just type that in and press equals. I'm not going to store it in a memory. I know we use that a lot. We use that with sign change, we use that with substituting values into integration. I'm just going to press 3 and xe. That means 3 is now the value of ans, the answer function. So what I'm going to type in is 4 minus 1 over answer. Answer is shift in that bottom. I'm going to press xe. I get 11 over 3. 3.6 correct. Already knew about that. But now the answer value is 11 over 3. So I just need to press xe again and it'll work out the next one. We already knew that one. But now that's the answer function, so I can just press it again. So x3, my third new guess, is going to be 8.7317. And you can see how each successive guess is getting closer. There's less variation. So I'm already getting the same answer to 2 decimal places. So I can say, right, to 2 decimal places, I'm pretty sure the root of the one root of this equation, there might be more, but one root of the equation is 3.73. I'm going to go on. Can I be even more accurate? Well, yeah, now I've got, for 2 successive answers, I've got the same answer to 4 decimal places. So I can now be pretty sure that my answer to 4 decimal places is 3.7320. That's one of the roots of the original equation. It might not be the only root. And if I keep going, then yeah, it's pretty much staying static. All it's doing is re-evaluating this calculation. We say that this has converged. This has converged to a particular value which gives us a root of the original equation. And we know with quadratics it might be the only root, there might be another root, but we found a root. We found a root. Now, this whole rearranging thing, how did we know that rearranging this equation to this and starting with 3 was going to work? Well, shall we rerun that process and start with a different value? Let's start with 4. Let's start with 4. So same equation, I'm going to make 4 mine. So go on, see what happens when you use 4 as your first guess. Same equation. So you should get the same answer?
Yeah. Yes, eventually.
This is when I do 2 skills. Maximum.
But that's not always going to be the case. It's not always going to be the case. So in this case, that rearrangement, working out there was a root between 3 and 4, and we were told that in the question, either of those was going to do, but it's not always going to be the case. So can I give you another equation and ask you to try and rearrange it yourself in the form that we're after? So it's x cubed plus 5x squared minus 2 equals 0. And I reckon there are 3 or 4 different ways that you can rearrange that as x equals something to do with x. So see if you can find a couple of different ways that that can be rearranged as x is equal to something to do with x.
Can x be 0?
Sorry?
Can x be 0? Well, actually, can you divide by x?
Oh, I see. Yes. X can't be 0, so you're allowed to divide by x. Sorry, yes, thank you.
Sweet. Just put anything.
So, George, have you got a rearrangement for me?
Oh, yeah, 2 over x squared minus 5.
So talk me through how you got that.
I added 2.
So you've got
And then divided by x squared. And then minus the 5.
so you divided by x squared and took away the 5.
Yeah.
Okay, that's good. So we can turn that into an iterative formula like this. Nice one, excellent. Go on, Grace, you got another rearrangement?
2 over x squared plus 5x.
Say again, sorry?
2 over x squared plus 5x.
So talk me through how you did that one.
Plus 2. Taking x off and then divide by 5x.
Fantastic. So we've got xn plus 1 is 2 over xn squared plus 5xn. Very good. You've got another one, Isabel?
9.
One that involves, has anyone got one that involves a square root? Johnny, could you rearrange it to give me one with a square root? So let's get the 5x squared on its own. So let's add the 2 and take away the x cubed. Let's divide by 5. And if we go with just the positive square root, that will find us one root. It might be there's a different square root. Now, so I'm going to give you a couple of starting values, and get you to just experiment with what happens with those 3 rearrangements when you apply this iterative process. Do they converge? Do they all converge on the same route? Are there any that do not converge? Are there any you can't do? And don't sort of feel it, go right down every stage. Just see if you can get to a particular solution. Remember to use the answer button, not the X button.
That's definitely.
Have you got a spare calculator, sir?
I have.
Please.
Is yours?
Why? We just keep it. Really.
Not sure.
Thanks.
Right, so let me show you the actual graph, okay? So this is what the actual graph of that function looks like, and remember the roots are where it crosses the x-axis. So did anyone get minus 4 point something, close to 5, minus 5?
Minus 4.9 was
And did anyone get something between 0 and minus 1? Did that come up with any of them? I didn't get that one.
0.54.
And did you get one between 0 and 1? Yes. So now it's at the moment it's a little bit of a dark art as to why some rearrangements give you some roots and some starting values give you other roots. So at the moment, we'll gloss over that. We will address that. We've got a nice, neat graphical way of showing you. But in general, it is possible to get an iteration that converges. Some do not. We'll meet some along the line that do not, and that's called diverging. But let's stick with ones that converge, and let's have a look at what exam questions along this line actually look like. So if you turn, if I give you a book and you turn in your book to page 281, we'll have a go at question 6. So 281 and question 6.
Video
281. So in this question, we are asked to do a rearrangement, except we're not given the outcome. We've got a couple of missing values there, so you've got to do a little bit of algebra to turn this equation into that. The clue is that you've got a cube root there, so hopefully that will indicate what you need to do. And then you're asked to use iteration using 0 as your first guess. But in this question, and this is very often what happens in exam questions, they don't ask you to keep going until you get the same answer. They're just asking you to write down the first 3 new values. So x0 is the first guess. They're asking you to write down 3 values, do 3 iterations, and in each case, write those answers to 3 decimal places. So you've got to do a bit of algebra first, get the x cubed on its own, and then cube root it. Suggest we do 6 and 8 now, and that leaves number 7 for you to try at home. Always start with an equals 0 equation. Hopefully that's what you got. P was a third. X to the 4 over 3 is the same as a third. And Q is minus 2. Have I got that right? It is minus 2? Yeah. So you're then going to do 0 equals to get that as your answer value. And then type in the left-hand side of the equation, right-hand side in the book, left-hand side as I've done it.
You haven't put cubed root.
Oh, thank you. Slightly worried I didn't reset right answer value. Has anyone else got the same? Is that?
Yeah.
Oh, right, that's good. Now we're only asked to go that far. I'm intrigued, so I'm going to go further just to see what happens. So it is thermally converging. Takes a while. So the question doesn't actually get us to use iteration to find that root. It just wants you to show that you can do iteration. So this is how I would set that out. So I've done the rearrangement, so I probably write P equals a third, Q is minus 2, and then I just go bang, 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 like that. And that's part B done. Part C brings us round to the end of last lesson. It gives you the value. So that's the value that we were actually getting there, weren't we? Yeah, minus 1.132, it was getting there. So it says, given that it's that value, show that it's that value. This is a sign change question. So we're saying it's that to 3 decimal places. It's not, it's a bit confusing with a negative number line, that would be minus 1.133, wouldn't it? And that is minus 1.131. So it's not that, show that it's that. So we do that using sign change by trying those two values there. We try those two values there in our original function. So we make x equal to minus 1.1325 and minus 1.1315. One of those hopefully will be negative, one of those will be positive. Every value between there and there is that to 3 decimal places, and there must be a root somewhere between there because of the sign change. So that's how we do part C. Sign change to demonstrate that we've got the right answer to 3 decimal places. Have a go at question 8 if you've finished that one. So in question 8, we're asked to do sign change at the beginning and the end. So to start with, we're going to make x equal to 0.8 and 0.9. We should get a positive and a negative answer. Remember, 4 cot x is 4 over tan x. Although to do the rearranging, you've got to write it as cos x over sin x. Remember the form of words, you don't have to sort of say it exactly that way, but the sign change indicates that alpha, which is what they're calling the root, is minus 1.132 to 3 decimal places. That's how they express it that way. So they always tend to write it, I say always, they tend to write it like this and then say, show the equation that equals 0. So I'm always, sorry, that's 7. Again, 8. I always start writing it again. So I'm going to start part B, writing cot as cos over sin. Again, part C only wants 3 iterations, only 3. sure you're in radians. It says that at the start. So, does it not say? No, you're right. No, that's interesting, isn't it? Does it work? Does it not work in the group? That might be interesting to see which would it. No, right. So I guess yes. So I mean, I often say this, don't I? I think there is a difference between the level of checking that goes through a textbook question and an exam question. So you would hope that an exam question they would be the sort of indication we've got in question A's. But I guess at least you've got the fact that it only works in one. So that's So the rearranging here, I add 8x to both sides. And then divide by 8. If you divide 4 times something by 8, you get half of it, so you get that. So that's your iterative rearrangement. We then start with 0.85. That makes sense because we got, we know there's a root between 0.8 and 0.9. So I've done 0.8, so let's see what happens here. So that's x1, x2, x3, that's are we asked to go on further? No, but this time we're asked to 4 decimal places, aren't we? That's all we're expected to do. I'm intrigued, so I'm going to keep going, see what happens. So this one's actually taking a bit of a while, isn't it?
It does take its sweet time.
Yeah, it's sort of oscillating between 2 values, isn't it? Eventually, it's sort of honing in, but yeah. Anyway, we don't need to worry about that. They're just asking us to use the iterative process to demonstrate how we can do it. Then, hopefully, having heard that it was 0.831, was that what we were getting?
Yeah.
Yes, right, okay, that's good. Having known that, we have to verify that. So you needed to try 0.8305 and 0.8315 in the original function. Remember, sign change is in the original equals 0 equation. So that's how you would have done that last part. So question 7 is a good one to try, and thanks to Charlie we know that we need to do it radians, so that's good. Now, everything we've done so far has worked. Does it always work? Well, the answer is no. So can we just very quickly finish with an example that doesn't work? So let's say we're trying to solve this equation. And so we rearrange it by adding x to both sides. That's a nice easy rearrangement. And we turn that into our iterative formula. And we're told to start with 2 as our first value. So can I get you just to see what happens when we do that? So what we get is a divergent iteration. So can I start from scratch? Oh, I can't remember. Anyway, so you get 2, and then obviously the next one you're going to get is 3, and then you're going to get 3 squared take 1, 8, and then you're going to get 63. So this is an example of an iteration that diverges, or it's divergent, and that's no good. That's no good. So how can I tell from a rearrangement or from a starting value whether it's going to be convergent or divergent? Well, the first thing to say is most exam questions are like the 2 that we've done, or the 3 some of you have done, 6, 7, 8. No need to worry. You're given the rearrangement, you're given the starting value. However, there are a couple of questions where you are expected to talk about whether it's going to converge or diverge, and it's a nice, neat graphical approach, which we'll do in tomorrow's lesson. So that's what we'll get to. So if you didn't get those done, finish number 8 and have a go at number 7. I have rearranged OneNote. I have, oh, that's big. What is that so big? I've created a little revision section, and this is in the content library, and in it I have put the linked PDF, which is the thing with the links to the exam questions, but also the link to the folder with all the example resources. And if you remember, you use this by finding a topic in the list and then identifying which of the topic tests it's from. And tomorrow, binomial, year 1 and year 2 binomial. That's our after school revision session tomorrow. Definitely worth doing, maybe even a little bit of probability. And yeah, we've got a lesson and a half left on numerical methods, a few lessons on vectors. We may even get some statistics done before Easter. Good stuff.